a particle of light fired from an emitter passes through a slit and impacts the screen. What if simply looking at the universe could change its very shape? This isn't science fiction. It's the core mystery of modern physics, quantum mechanics. And now, the one trying to answer this question is no longer just human. Search YouTube and you'll find countless videos like this. Many of you may have felt a thrill upon discovering this truth of the universe. The idea that human consciousness directly affects the universe itself. If true, how poetic and how full of hope that would be. The stars shine because I look at them. Feeling that way, we feel a strange, profound connection to the cosmos. But is physics really that convenient? First, let's review the basics of the double-slit experiment. Particles such as photons or electrons are fired toward two narrow slits. On the screen behind, you would expect to see two simple bands, or so we thought. Here, something strange happens. What appeared before the experimenters was an unexpected pattern of multiple fringes, an interference pattern. This implies that each particle passed through both slits at the same time. In other words, a single particle is behaving not as a solid marble, but as a wave. Waves overlap, reinforcing and cancelling each other out. Even when firing particles one by one, the interference pattern still emerges. So researchers tried something else. Let's place a detector to see which slit the particle actually passed through. And then the pattern vanished. Suddenly, the particles began behaving like ordinary physical bullets. How should we interpret this phenomenon? Here, a genius proposed a daring hypothesis. Mathematician John von Neumann. In 1932, he formalized the mathematical foundations of quantum mechanics. Within his framework, there was room for a radical interpretation. The collapse of the wave function, the disappearance of the pattern, occurs when a conscious observer intervenes. Physicist Eugene Wigner pushed this even further. His thought experiment, Wigner's friend, suggested that a particle's state remains undefined until a conscious mind steps in to observe it. This idea leaked into textbooks, popular science magazines, New Age philosophy, and eventually flooded across YouTube. Thus, the urban legend was born. Consciousness creates reality. Many people hold this popular belief. The interference pattern only vanished when a conscious being observes it. Then, let us ask, does an AI possess consciousness? When an AI observes the experiment, does the pattern vanish or does it remain? A seemingly simple question, yet profoundly deep. To find the answer, we must first carefully unravel what is actually destroying the pattern. Let's start with a straightforward case. Suppose we use AI integrated with a camera or sensor as an observation device. The camera images the particle, and the AI analyzes the data to determine which path it took. What happens to the pattern in this case? The answer is clear. The pattern vanishes. But the crucial question is, why? And it is not because the AI made a judgment. The moment the camera interacts with the particle, it has already disappeared. The instant a sensor detects a photon, the particle's quantum state becomes entangled with the apparatus. Physical, which path information is now registered in the universe. Whether the AI reads that data or not, even if no human ever looks at the screen, and even if you unplug the machine and wipe the hard drive, decoherence has already occurred. In short, regardless of whether AI has consciousness or not, the interference pattern disappears. The moment the physical interaction occurs, the wave collapses into a particle state. Therefore, the conclusion is, you cannot determine whether an AI has consciousness by showing it the double-slit experiment. The interpretations by von Neumann and Wigner were serious hypotheses considered during the dawn of quantum physics. However, the vast majority of modern physicists no longer support the idea that consciousness plays a special role. The physical framework of quantum decoherence explains the phenomenon completely. Through this thought experiment, we learned that the double-slit experiment cannot prove or disprove AI consciousness. The universe doesn't care who's watching. It only cares that it was touched. And perhaps that is the most beautiful truth of all. Does an AI dream? If we confront AI with this question, how will it respond? The answer was astonishing. The AI's response, its response was far beyond anything we had imagined, truly fascinating.